What do you look forward for every Christmas and New Year's Eve, aside from the food, family gatherings, and gift giving? For sure, you're also looking forward for the fireworks display. We often see beautiful fireworks in the night sky. These are one of the most spectacular outdoor shows that we often look forward to. They produce amazing bursts of colors that take a variety of shapes. But do you ever wonder how fireworks are made and how does it produce amazing colors in the night sky? Now, we are here to explain to you the physics behind this phenomenon. Fire. We use it to cook, light our candles, and keep us warm. Hundreds and hundreds of years ago, there was also fire. Of course. Well, people back then were probably like, ooh, glowing. Ooh, fire. Fire! Or something like that. I know nothing about the history of fire or who gave birth to it, but all I know is that it has colors, usually light yellow or orange yellow. Anyway, hundreds of years forward, people invented fireworks. Ooh, firework. What firework? Well, a firework, my friend, is like a fire but much, much cooler. You see, not like the fire we know, it can have different colors such as green, white, deep red, green, white, and many more. How? Well, you are lucky because in this video, we will be learning why that happened, how that happened, and what happened. Anyway, welcome to the physics of fireworks. Fireworks are carefully made to create wonderful colors and bright night celebrations, a little spark. Fireworks are made out of mortar or a container, a shell, a fuse, lift charge, black powder, fuse, timed fuse, burst charge, and finally, stars. I know what you're thinking. What are those things? Well, let's go through them one by one. Okay, now first we have is the container or the mortar. This tall cylinder holds the shell until it is launched. The shell often comes in the form of a paper sphere packed as two halves. It is filled with stars designed to produce a specific effect in the sky. The bottom of the shell contains a lift charge that launches the shell out of the mortar. The lift charge is made out of black powder. When ignited, it launches the shell out of the mortar and into the sky. The black powder is invented in China over 1,000 years ago. This is a type of gunpowder made from 75% potassium nitrate and 15% charcoal and 10% sulfur. The fuse carries heat to activate the black powder. The timed fuse activates the burst charge within the firework. The burst charge is located at the center of the shell. This ignites the stars within the firework. And finally, the stars. These small pellets are made out of chemicals such as powdered metal salts. When ignited, they create the fireworks' special sound and light effects. And now we know what fireworks are made of. But let's know more about them.
It's a bird!
No!
It's a plane?
No!
Then what is that?
It's fireworks!
Wow! Do fireworks fly?
Of course it can!
How is it possible? It doesn't have wings!
Fireworks are designed like small rockets. It contains chemicals that when ignited or exposed to heat and electricity, it will fly up in the sky, creating a scenic view. It is possible that fireworks can fly even without wings. Physics is on the rescue. It can explain this kind of phenomenon. The process is called liftoff. It involves principles of physics related to Newton's laws of motion, particularly the third law, which states that for every action, there is an equal and opposite reaction. Fireworks use this law to generate the necessary force to propel themselves into the sky. I will give simplified explanations based on the physics behind liftoff in fireworks. According to Newton's third law, As the fireworks expel gas downward due to combustion, an equal and opposite reaction occurs, propelling the fireworks upward. The expelled gas acts as a propellant, generating a force that pushes the fireworks in the opposite direction. Opposite direction kay samtang gapagawas ang fireworks ng gas sa paubos na direksyon, katong gas na napagawas mamahimo tong rason nganong makabuhat og force para mapasaka ang fireworks sa kalangitan.
Wow, fantastic! Even though fireworks don't have wings, they can still fly.
That's right! Now you know, kay sa physics ang kaalaman siksik.
Hey there! Ever wonder what's behind those amazing sounds fireworks make? Well, buckle up because we're diving into the science that sparks the booms, crackles, and whistles, turning the sky into a symphony of sounds.
Fireworks explode, releasing hot gas and energy causing a thunderous bang. The crackling noises, they're like a fusion of light and sound created by a tiny component. Certain elements in the fireworks produce mesmerizing crackles.
Whistling sounds during ascent, physics at play. Air vibrations interact with the firework tube, creating a distinct whistles. These sounds illuminate the night sky, a result of explosive reactions and clever firework design.
That thunderous noise, it's a shockwave traveling through the air just like ripples on water. It's science, it's spectacular, and it's the boom behind the fireworks.
Fireworks not only come with a loud boom, but also mesmerizing patterns. Now you might wonder, what decides the beautiful patterns in fireworks? Since we already have learned about the anatomy of fireworks, which part do you think is responsible for the patterns? Shells? That is right! Patterns are mainly contributed by the shell, specifically the stars. So what are stars? Stars are pieces of metal salts which are arranged properly inside the aerial shell. There are three things that contribute to the patterns of the fireworks. The first one, use of various shapes and sizes of shells. A round shell will create a round burst in the sky, while a shell shaped like a ring will create a ring-shaped burst. The second one, use of different composition of chemicals. Different chemical compositions can also create different colors. The use of various shapes and composition allow the creation of various patterns such as the stars, hearts, and even text in the sky. The third one, the placement of shells in the mortar also contributes to the pattern. For instance, multiple shells are placed in a circular pattern in the mortar. It can create a spherical pattern in the sky when they are all ignited at the same time. Now let us examine this image of a shell. If you observe closely, there are three different arrangements of spherical and cubic metal salts mixed with gunpowder. The three different shell arrangements will create three levels of explosion, but all of them will come out as spherical in shape. When watching firework displays, you might notice a delay in between the patterns. That is because the thin arrangement of gunpowder ensures separation of consecutive explosions, which happens with some delay at some distance farther from the last one. And that is how the patterns of fireworks are made. Hey Laika and Karim, can you explain the last topic for the physics of fireworks? Sure! Maybe your fireworks. Wait, what? Let us go back to the main topic. Now, when you see fireworks, what do you usually observe?
Different colors. Now, do you even wonder how these fireworks produce such beautiful colors? Now let us tell you a trivia. Fireworks produces beautiful color combination in the night sky through various metal elements present in it.
Certain elements like strontium, calcium, sodium, barium, and many more emits energy corresponding to the energy of one of the 7 colors of rainbow, or sometimes even different shades.
But what makes fireworks colorful? Let us first take off to the word incandescence. It is the emission of visible light by a body caused by its high temperature. Incandescent light is produced when a substance is heated so much that it begins to glow. Heat causes a substance to become hot, initially emitting infrared, then red, orange, yellow, and white light as it becomes increasingly hotter. Take for example when you light a candle. When the temperature of a firework is controlled, the glow of its metallic substances can be manipulated to be a desired color at the proper time. More often, light from fireworks is produced by luminescence. When fireworks explode in the sky, the gunpowder reaction creates a lot of heat, causing the metallic substances present in the stars to absorb energy from the heat and emit light. And these metallic substances are actually metal salts which produce luminescent light of different colors when they are dispersed in the air.
But what do really happen with the electrons present in these elements when they are heated? Let me show you a diagram of the Bohr model. This is the Bohr model. Take for example the calcium, which has 20 number of electrons. When this calcium atom is heated, the flame or energy that is applied to the calcium atom will excite the electrons present in it, releasing excess energy in the form of light called photon, thus producing the color orange. But what are the behavior of the electrons when it is heated? Imagine an atom as a tiny solar system with electrons orbiting around a central nucleus. These electrons are arranged in different energy levels. When you expose the element to heat, it gives extra energy to these electrons, causing them to get all excited and jump to higher energy levels or other parts or shells of the Bohr model. Now the thing is, these electrons can't stay excited forever. They want to go back to their usual calm state. And when they do, they release the extra energy they got in the form of light. This light has a specific color, and that color is like a fingerprint for each element. It's unique to that element like a signature. The absorbed energy excites the electrons to higher energy levels or even ejects them from their orbits. The energy absorbed is specific to each element, leading to discrete electronic transitions. As the excited electrons return to their original lower energy levels, they release the excess energy in the form of light. This light emission corresponds to a specific wavelength or color, according to the energy difference between the excited and relaxed states. In another lens, take for example of this diagram. In the principle of luminescence, heating atoms causes electrons to move from their ground energy level to a higher energy level, which is indicated as the blue arrow. When the excited electrons move to a lower energy level, which is indicated red arrow, they emit light with a specific energy and characteristic color. These electrons absorb energy from the heat, which causes them to move from their original ground energy state to an excited state. Then, nearly immediately, these electrons go to a lower energy state and emit the light with a particular energy and characteristic color. Now, how does each element have its own color? In such, different elements produce characteristic colors. For example, strontium salts, lithium carbonate, and strontium carbonate produces color red.
The calcium salts, calcium chloride produces orange.
Sodium salts, sodium chloride produces color yellow.
The barium compound and chlorine producer barium chloride produce green.
The copper compounds and chlorine producer copper chloride produces blue.
The mixture of strontium red and copper blue compounds produces purple.
The explanation behind this is that each element has a unique arrangement of electrons in its atomic structure, with specific energy levels and sublevels. Each element or atom has different number of shells and different number of electrons present in it, thus giving the electrons more options to jump to different shells. Consequently, the energy levels available for electrons to move between are specific to each element. As a result, The emitted light has a characteristic color that is unique to that element. So when scientists see a certain color of light coming from a substance, they can tell which element it is, just like recognizing someone by their unique handwriting.
This helps scientists identify elements in different materials, whether it's in chemistry lab
Or even in distant stars in the sky.